Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this video, I'd like to ask you to please subscribe to the channel, give this video a thumbs up, and engage with a comment below. Today's video is going to look at Unit 1, Lesson 21, 180. The learning goal says we're going to prove the triangle angle sum theorem. So what they're talking about is proving that every triangle, if you add the three interior angles, will always add up to 180 degrees. We have one learning target today. Once we're done with the practice problems, we will come back and review this learning target just to make sure you understand everything you need to before moving on to future lessons. The learning target for this lesson says that you can prove the angles in a triangle sum to 180 degrees. This is going to be a very important thing to understand because it's going to help you have this knowledge base in order to solve future problems. So now that we've got the introduction out of the way, let's go ahead and start on the practice problems. All right, let's go ahead and begin with practice problem number 1. The triangles here are each obtained by applying rigid motions to triangle 1. So we're starting with that bottom left triangle. So I'm going to go ahead and I'm going to highlight this in blue. So this is the triangle we're talking about. Number 1, which triangles are translations of triangle 1? So remember that translations mean sliding up, down, left, or right. So we are not rotating them clockwise or counterclockwise. We are not reflecting them across an axis of reflection. We're simply sliding them up, down, left, or right. And they're asking which triangles could we create simply by translating them up, left, down, or right. And in this case, it would be all of the odd numbered. They're facing the same direction. They look exactly the same. They're just up or to the right of that original triangle. So this means the odd numbered triangles are translations. So I'm going to pick a different color here. We'll go with green. I'm going to highlight the word translations in green. And then that way we understand that we are saying all of these odd numbered triangles are the ones that are formed simply by translating. So that takes care of number 1. Now, number 2 wants to know which triangles are not translations of triangle 1. So that's going to leave the even numbered. We could get them by reflecting. We could reflect number 1 across this upper right line and create number 2. And then we could translate from number 2 to make the rest of them. Or we could rotate number 1 180 degrees, and then we could slide up and over, or translate up and over to the even numbered ones. So the even numbered triangles are not translations of triangle 1. And we know that because they are upside down. So to make this clear, I'm going to highlight not translations in yellow. And that means we're talking about all of the even numbered triangles that I will outline in yellow. So I hope this explanation makes sense to you. I hope the colorization helps you understand which ones we're talking about. But if you do still have any questions, feel free to leave a comment below. Now let's go ahead and take a look at practice problem number 2. Practice problem number 2 is going to be the last practice problem we work on in this lesson. When we do this, I'm going to go ahead and solve the problem as it is, but the learning target on this lesson was to prove that triangles have an interior angle sum of 180 degrees. So I'm going to add that on to this problem to make sure that we achieve that learning target, being able to show that. So first, let's just worry about the question the way that it's answered. It says the quadrilateral is a parallelogram. So each opposite side lines are parallel to each other is what they're telling us. They give us one angle. The bottom left angle is 80 degrees. And they want us to find angles 1, 2, and 3. So here's how we're going to do that. If I know that this is a parallelogram, then I know that this top line, 1, 2, and this bottom line, the 80 degrees to the 3, I know that these two lines are parallel to each other. And then we can call this line going through number 1 and the 80 degrees, we can call that the transverse. And as we have learned in previous lessons, when we have parallel lines that are cut by a transversal, the opposite interior angles are the same. So if this angle here is 80 degrees, then we know that this angle here is also 80 degrees because they're opposite interior angles. And that means this angle up here, number 1, is going to be the same as this angle here, number 2. Now, what I know is that for a straight line, my angles need to add to 180 degrees. So that means I can take this 80-degree angle at the top plus angle number 1 is going to equal 180 degrees. I can subtract the 80 degrees from both sides, and that tells me that angle number 1 equals 100 degrees. So this is a 100-degree angle, and so is this. Now, once we have figured that out, we can start looking at this on the other side. If I say that this line on the right and this line on the left are parallel, because that's what they told us, it's a parallelogram, and I use this line across the top as my transversal, then again I know that my opposite interior angles are going to be the same. So that means if this angle number 1 is 100 degrees, then that means this angle here is also 100 degrees. Then I know that in order to make a straight line, it's going to be 180 degrees. So just like we did previously, I can say that I know that 100-degree angle that I just labeled in blue plus angle number 2 are going to have to add to 180 degrees. I subtract 100 degrees from both sides, and that tells me that angle number 2 must be 80 degrees. So this is an 80-degree angle. And there's two ways to get this last one. I could choose another set of parallels and another transversal and do the same thing I did to find the first two angles. Or squares, just like circles, are going to be 360 degrees. Inside. So that means I have 80 degrees plus 100 degrees plus 80 degrees plus angle 3 is going to equal 360 degrees. If I add the three angles together that I know, then that is 260 degrees plus angle number 3 equals 360 degrees. Subtract 260 degrees from both sides, and we find out that angle number 3 must be 100 degrees. So now we've solved the problem as far as they put it. Now I want to expand on this and show our learning target, proving that triangles are going to have 180 degrees. So if I were to use the top and bottom line parallel, and then I were to cut them with a transversal diagonally through points 1 and 3, then I have created two triangles. Now in doing so, I've created two angles on the top and two angles in this bottom right. So for these angles that we just created, we might assume that it cuts this top left corner and this bottom right corner in half, but we don't know for sure. What we can do is we can label this angle as A and this angle as B, and because these are parallel lines cut by the green line transversal, then opposite interior angles are going to be the same. So if this angle at the top is A, then this angle at the bottom is A. And if this angle in the top left is B, then the opposite interior angle is also B. So I have two triangles here, and I know that these triangles are going to be 80 degrees plus A plus B. Now, what I do know is that whether I look at this top left corner or whether I look at this bottom right corner, A plus B gives us the full 100 degrees. So I can replace A plus B with 100 degrees. And when I do, I see that my triangle has 180 degrees. That's one way to prove it. Another way to think about it is that we just cut a parallelogram in half diagonally. We know that the full parallelogram is going to be 360 degrees. I should go back and fix my wording down here in the bottom left. This isn't a square, it's a parallelogram. But the same thing holds true. I took a parallelogram that was 360 degrees. I cut it in half and made two similar triangles. So I took 360 degrees and I cut it in half. And now each triangle has 180 degrees. But this is a way that you could prove that. I know they both have an 80-degree angle. I know that because I used parallel lines and I cut them with a transversal, I know that the opposite interior angles are going to be the same. So I can mark one as A and one as B, and then the opposite is true in the other corner. So now I'm adding that A and B together and getting 100 degrees. So when I add the 80 and the 100, I do get that 180. I hope this makes sense to you, but if you do still have any more questions, you can leave a comment below. Now, before we end the video, let's go back, review that learning target, and just make sure you understand everything you need to before moving to any further lessons. So looking at our learning target, the one learning target for this lesson was to prove the angles in a triangle sum to 180 degrees. So I extended that second problem in order to get some of this in there. But I'm going to go ahead and give you another example right here just to show what I'm talking about. So let's say we have some random triangle. And we've got angles A, B, and C. Now, what I can do is I can use the bottom of this triangle and then on the top point, I can draw another line that is parallel. So now that I know these lines are parallel, if I say that this left side of the triangle is a transversal, then because I have two parallel lines cut by a transversal, I know that the opposite interior angles are the same. So if this bottom corner here is A, then the opposite interior corner is also A. And then the same thing on the right side of this triangle. If I say, okay, top and bottom are parallel, then the transversal cutting the two parallel lines creates opposite interior angles that are the same. So if this bottom right corner of the triangle is C, then its opposite interior angle is also C. And now if you look at the top, I see that I have this straight horizontal line, which means A, B, and C must equal 180 degrees because of the straight line at the top. And because A, B, and C added together equals 180 degrees for this line at the top, then that means when I add A, B, and C inside the triangle, it also has to be 180 degrees. So this is another way to prove that this is true. So now, if you understand this, you can take this and apply it when you see situations that it helps you solve problems in the future. I hope this makes sense to you. I hope you found this video helpful. If you did, please give it a thumbs up and engage with a comment below. If you find this series of videos helpful, then in the bottom left corner of the screen, you should see a recommendation of another video that YouTube thinks you'll find helpful. In the bottom right corner of the screen, you'll see the subscribe button. It would really help the channel if you would subscribe. And I look forward to seeing you in the next lesson.